Welcome back, Night Owls. This is Dr. Nighttime. And tonight I'd like to present a formula, or a derivation of a formula, that you've probably seen for a while. It's the formula for the volume of a pyramid. This will be a probability-based approach to the formula. Notice that this means we won't need to use calculus. I know you could relatively easily derive the formula for volume of a pyramid using calculus, either integrating by cross-sections or some other integration technique. But because this is a formula that's typically presented in around middle school, I figured I'd present a derivation of the formula that doesn't involve anything more complicated than that. And the probability that I'll be using here will be relatively simple probability that you probably encountered around middle school. So the trick here, you take your pyramid, and I'm going to fit this pyramid inside of a box. So I've got this pyramid with a base x by y, right, rectangular base of the pyramid, and height z, and I just fit it inside a box that goes x by y by z. And clearly, right, volume of the box is x times y times z. And we know the formula for volume of a pyramid is 1/3 base times height. That would be 1/3 x times y times z. Now I can ask, what fraction of the box is also inside the pyramid? Now, if I know the formula for volume of a pyramid, I'd say, okay, it's got to be 1/3. Alternately, if I can say that there's a 1/3 probability that any point randomly inside this box is also inside the pyramid, then that's another way of showing that the volume must be 1/3 base times height. So now I'll pick a point somewhere inside this box. And I want to say, what's the probability that's also inside the pyramid? So for any given point I pick, I'm going to declare x, y, and z to be the coordinate distances, the distances along the main coordinate axes to the vertex of the pyramid. So picking this one here, I go this much in the z direction, this much in the y direction, this much in the x direction. Those will be little x, little y, and little z. Then I want to normalize them. I want to divide x, y, and z by their maximum possible value. So the furthest away you can be from the vertex in the x direction is 1/2 x, because the vertex is halfway across. It's halfway through the top face, in the center of the top face. So you've got x over 2 in each of these two directions. You have a distance y over 2 that you can go in each of these two directions. And you can go all the way down to z here. Notice, when I talk about distances, I'm talking about the absolute distances, not worrying about whether they're positive or negative. So little x, little y, and little z will always be positive. I'm going to divide little x by 0.5 big X. That's going to be, I'm dividing little x by its maximum amount. I'll divide y by its maximum amount. I'll divide z by its maximum amount, the big Z. And that will get me the random variables alpha, beta, and gamma. Random because it applies to some random point somewhere in the box. So you'll notice alpha, beta, and gamma are independent, uniform random variables between 0 and 1. If you're right at the vertex, each of them is 0. If you're down at one of these four corners, each of them is 1. Now if you're right down here, z is 1, x and y are both 0. So you've got independent, identically distributed, uniform variables between 0 and 1. And we have to ask, well, when will the point be inside the pyramid? You realize that gamma has to be the largest of the three variables of alpha, beta, and gamma. Right? Because you pick your gamma value, the moment your alpha is too big or your beta is too big, then you leave the pyramid. And of three independent, identically distributed random variables, or I've got these three random numbers somewhere between 0 and 1, there's a 1/3 probability that any given one of them is the biggest. So, there's a 1/3 probability that gamma is the biggest of alpha, beta, and gamma. Therefore, there's a 1/3 probability that a randomly chosen point will be inside the pyramid, given that it's in the box. Therefore, the pyramid has to have 1/3 the volume of the box. 1/3 x, y, z. 1/3 base times height. As always, I hope you found this useful and found it an interesting explanation. If you liked it, feel free to click the link in the description below. And until next time, this is Dr. Nighttime wishing you a good night.